Hey guys, it's Mr. Letterrock. You are probably sitting in room 311 right now as we speak. This is my cat. Say hi. He doesn't want to be here right now. But I am talking to you today about the 6 types of chemical equations. Good morning. It is now Monday morning for me. For you, it should be Monday afternoon, Monday night when you're watching this. Some of you, it'll be on Tuesday. Some of you are watching this right now for the first time on Wednesday. Today we're going to be talking about the 6 types of chemical reactions, and I'm just going to dive right in here. I'm going to start off with my favorite. It's my favorite because it has to do with fire, and I kind of love fire. So, really, when we're talking about combustion here, you're talking about any compound at all that burns. So anything that you can burn. And the most flammable things happen to be a lot of this stuff over here, right? All of our covalent bonded, the stuff that we are made out of is mostly over here, right? So carbon-based, carbon especially here, plays a big role. Because obviously carbon is wood, wood burns. But some of you, let me just give you an example of what an equation like this would look like. I'm going to use butane because I would assume that by this point in your life you've probably lit in a lighter before, and that's what's in a lighter. So some of you may have played with matches. That's just carbon. That's what the carbon does. It has a little bit of flint there to start the ignition and react to the oxygen. But that is the next most important thing, is that you have to add the oxygen here. And what we use as a catalyst is heat, all right? So we bring to combine these two things, you need the catalyst of heat, and you would have the butane, or C4H10, with the oxygen, and this produces two things you're very familiar with, which is carbon dioxide and water. All right. So anytime you see some compound mixed with O2 on the left side, you're going to get carbon dioxide and H2O. All right. And so that would be one example there for you of a combustion reaction. The next one is synthesis. And synthesis, or you can also call this combination, this is when you have a compound that is created by combining two other things. So it'd be, this could be any multiple variety of things, but you would combine these two things, the A and B, and it would become AB. So a better example of that, maybe a more real-life example of that, would be when you take iron, so you take Fe, and you combine sulfur, which is our S, and it becomes iron sulfide. Right? You remember how to say iron sulfide? Remember this coming back to you slowly, maybe? So that is an example of your synthesis equation. This is not completely correct. There are some things that we're going to be doing with stoichiometry next week. So you're going to learn more about that next week. Stoichiometry. I know it's a big scary word, but that's what we're hopping into next. The third type, number 3, we are looking at decomposition. So when I say decomposition, I'm obviously talking about things decomposing. And just like combination was things coming together, decomposition is going to be things coming apart. So if we had our AB on the left side of the arrow, it would then go to A plus B, right? And these can be any variety of things. These are your unknowns. You could call them X or Y too. Here in this situation, I'm using A and B, but they're unknowns at the moment. A more real-life scenario here, one that happens very often, is water will break down into hydrogen and oxygen. So you have H2O going to hydrogen and oxygen. And here we have to, we'll get into this more, but oxygen is O2. See how they're not balanced? We're going to learn how to balance them. It's going to be really exciting. In this case, I would slap a 2 in front of that, and a 2 in front of this, and now we have 4 hydrogens on this side, and we have 2 oxygens on this side, 2 hydrogens on this side, and 2 oxygens on this side, alright? So, continuing on here. Let's see, the next one we're going to do is acid-base. And actually, I'm going to teach you the acid-base now, and we are going to learn more about single and double displacement at another time, alright? So the final one is acid-base. I took my time with this because this is probably the toughest one to really understand. I've been trying to show you guys lists of a lot of different acids and bases, and that's in preparation so that you can correctly identify these kind of equations. So here we talked about the one thing that all acids have in base. What is that magical element on this periodic table here that lets you know that it is a acid? Say it out loud in class if you know it right now. Hydrogen, right? So we're looking for anything that's combining with hydrogen. So if we look at this like we did before with A's and B's representing different elements and compounds, you would be looking at H, hydrogen, with some other thing here. I mean, this could be a wide variety of other compounds. And you're also looking then for a base. And remember that our big indicator there was OH, right? Like sodium hydroxide, all of these different ones. And so you're looking for something with a base, all right? And then this goes to, remember that this results then in water, so that's your big indicator there. So if you're looking for an acid and a base producing water, and then also in this case it would be some other compound from the A's and B's here. Alright, so just to give you a quick example, wipe that off here. Quick example, just a real simple one, hydrobromic acid. So we can say HBr. You should hopefully know that is hydrobromic acid at this point. And I'm just going to use sodium hydroxide, NaOH. So to see that, NaOH. And it is going to go to water, H2O. And in this case, we're looking at NaBr, or sodium bromide, right? Sodium bromide. So that's all the movie for today. I'm going to review all of these with the PowerPoint here and teach you more about single and double displacement. And thanks for doing your homework. Those of you who did it, I appreciate it. You will be rewarded. Have a good day.